Okay, so this is part 3 now, and we are looking at chapter 6 and 7, the last two of the book, which is binomial distribution and hypothesis testing. And the first skill, which I call skill number 12, we need to use how do we find the probabilities using calculator. So have a look, people. If you have an idea, do that yourself, like you always do. Pause the video and you come back and check with my recordings. The first thing you need to understand that calculator, if there's an inequality, only helps me, normal calculator like this one, CG50 does it both ways, but this calculator only helps me to work out the probabilities when x is less than equal to something. Okay, so my first priority is to change all the inequalities into this form. If I can, this one is sorted straight away. Okay, so this one needs to be changed and we need to do something about this as well. Okay, have a little pause and try and see if you can write it and check with my answers. Right, so I'm not going to rush on this one, part A. I'll try and explain to you. There's good. X is a binomial distributed. N is 37. That means there can be 37 attempts and probability of success is 0.65. I need to find out what is the probability of that success to happen more than 20 times. So this is more than 20, right? There's 30. I can have success 0 times, or I can have success full 37 times, okay, if I'm lucky. Then 20 is here, 21, 22, and so on, 19. I want, in this question, success to happen more than 20 times. That means I want 21, 22, 23, all up to 37. So I need to do what? I have to write this as 1 take away probability of x less than or equal to the biggest number which I do not want. So I want 21, so 20 is the biggest number I do not want. People, this is how the first thing will be changed so that it becomes calculator friendly. Okay, have a look, pause and check if you understand this. Okay, if you did, I would like you to change these 3 inequalities to make them calculator friendly. That means I want into this form. Okay, take your time and do it. Pause the video one more time and check. Okay, so I'll help you here. This say x is greater than or equal to 15 or at least 15 if you use words there. That means what do I want? I want 15 onwards, everything 15, 16, 17 and so on. So people, what do I do not want? The biggest number which I do not want is 14 this time. So 1 minus probability of x less than or equal to 14. Understand that very well, please. Okay. And similarly, I do not want 8. I want bigger than 8. So I'm starting from 9. So biggest number which I do not want here is 8. It helps if you make this number and if they're struggling people. Okay, over here, this is in correct direction, but it's not the inequality. This is a strict inequality. I want it in this form. So I want less than 9. That means I want up to 8. So now these 3 inequalities in this form are ready for me to use calculator. Then I'm going to show you how do we use calculators for this now. Right, for the calculators now, people, we go to distribution and come to binomial CD. If there's inequality less than or equal to direction, we go to binomial CD. Okay, then go to variable and press the 3 things. I want x to be, for this question, I want x, let's do this one first. I want x to be 8. Okay, x to be 8. And I want n and p as 37 and 0.65. So n is 37 and this is 0.65 press equals, and I get 0.5807. So my probability here is 0.5807. Okay, I'll do this one now. Greater than or equal to 20. So less than or equal to 20 I have to do. So guys, I'll go back there. Okay, so nx is 20. This is 37. Okay, that is 0.65. Right, execute. So this, I got 0.1177. Okay, but this isn't the answer I want because I want to take away from 1. So I go back and take away from 1 from there. Okay, and get the answer. So I do 1, take away the answer, but I'm going back home and calculate, and 0.8882 is the answer for this probability, 0.8882. Obviously, these questions are from the book, so you can always check that, okay? That's the first bit done. Well, this is straightforward. I'm expecting you to do that yourself, okay? Part D is different because this is equal to, so what do I do in this way? We do binomial PD. I call it point distribution, which is at a particular point, no inequality. So I go back to home, people. Okay, I go back to distribution. I press binomial PD this time. I press variable again. Okay, and press X is equal to 23, right? And the other two things are same. So I go back and execute, and that gives me 0.1258. This is 0.1258. Right, so we've done these three, and this one now is slightly tricky. I would like you to see if you can make it calculator friendly. And if it isn't easy for you to see, so I will still advise number line. It always works. Okay, let's call that 15 here, 14 here, 16 here, 20 here, 19 here, and 21, and so on up to 37. I want 15 because x is greater than or equal to 15. 15, 16, I do not want 20, so I want only up to 19. So people, I'm looking at this. If I start from 0 and get up to 19, I get x is less than or equal to 19. Everything up to 19. Okay. Then what's the biggest number I do not want is 14. So take away from it probability of x less than or equal to 14. So guys, this will be probability of x less than or equal to 19 and take away probability of x less than or equal to 14. So do that in the calculator and you should get that answer. And this is the answer for this one. So once again, we've done binomial cumulative distribution and we have done binomial PD as well. In both the cases, we've done inequalities. We've done inequalities in the other direction, which is the greater than. Right, we move on to next scale now. The next question is still under 12 binomial distribution, but you need to find the value of x this time when the probability is given. Have a look, people, make a story about it, and then check with my solution. This is a question in the reverse order. You must have noticed it by now that you got the probability and you're going to find the value of x. But luckily, this inequality is in the direction where the calculator works or the tables work. I'll tell you, people, if you have a number which is given to you in the tables and the table booklets, I show that, and the probability as well. So n equals 40 and probability 0.10. I have that given to me. So I'll just note this down. When x is less than or equal to 0 or just equal to 0, probability 0.0148, and I want probability to be less than 0.02, which is less than, so that's fine. When x is less than or equal to 1, it is 0.0805, and that becomes bigger than this. Okay, so what does that mean? 0.08 is becomes bigger than 0.02. So people, that means x is, what does that mean, people? When x is probability of x less than or equal to 0 is 0.0148, that is less than 0.02. Probability of x less than or equal to 1 is 0.0805. That is not what we want. But if you look at it carefully, it says x is less than k, and this probability is x is less than 1. Right? Less than 1 equals less means same thing as less than or equal to 0 or just equal to 0. So guys, in this case, k is equal to 1. Okay, tables make it very easy, but sometimes they're not given, these values will not be in the table, then we have to use the calculator. I'll show you how. So for the calculator, you go to distribution, and then you go to binomial CD, because that's what we're looking for, and list function this time. And you see a table, and the table is x values here and probability here. Probability will generate automatically. So I put the x values, and because I'm looking at the lower end, so I'm starting from x values from 0, then 1, then 2, then 3 and 4. And I stop here, check what happens, execute, I put n equals 40 there. and which is the case in 0.1. So execute there, n equals 40, 40, execute, then 0.1 is done. So that's executing it. It generates the probabilities, and the probability x equals 0 is 0.0147. So which is what we wanted. And probability x equals 1 is 0.08, becomes more than 0.02. So this is the only case which we have. So probability x equals 0 or probability x less than 1. That means that k equals 1. Okay, that is on the left side tail when you have to work out x probability is given. For this question, this is on the upper tail now. I want to find a probability of x greater than a number is less than 0.01. My tables or my calculator does not give me probability in this direction. Tables also give me probability in the less than or equal to. So I'm going to say, if I'm looking from the tables, so I'm looking for probability when it is bigger than 0.99. When's the last time it becomes smaller than 0.99? We check the tables and we see the values here. I get 8 as 0.9845 and 9 as 0.9949. So these are the two values. Okay, so probability x less than equal to 8 and probability x less than equal to 9. I'm going to test and see what do I get for the results. So then we decide which one is the value of my R. So these are the two probability values which get from the table. We want to see in this direction. So if it is x is less than equal to 8, that means one take away probability x greater than 8 with that. Okay. So so probability of x greater than 8 is, so probability of x greater than 8 should be 1 take away 0.9845, and this is greater than 0.01. Okay, so I don't want that. And 1 take away probability of x greater than 9 is that number. So I get probability of x greater than 9 is less than, this will be less than 0.01. So that's the number I want. So people, my R equals 9. Okay, I'm going to try and show this to you. How do we use calculator to work that out? With the calculator, same question, we have done the lower end. And you can see as x is less than or equal to 3, probability is 0.4231. We're looking at 0.99 or something like this, okay? And we will go, we have to go further down. So guys, what you need to do is you have to type a bit more numbers and see what happens, okay? Let me first tell you what are we looking for in the calculator. This is probability of x greater than c. That means this is probability of x less than or equal to c. 1 minus that, right? Because you want bigger than c, so up to c we don't want, and should be less than 0.01. We rearrange this and we get, I take this to the other side, we make it positive. To bring this to, so I get probability of x less than or equal to c is greater than 0.99. People, this is what we're looking for in this case in the calculator or in the tables. Okay, so I got the calculators, I put the values in, and I want to see the first time when probability crosses 0.99. So when x is equal to 9, it is x equals 8, sorry, it is 0.98, and when x is equal to 9 here, it crosses 0.99. So guys, when x is less than or equal to 9, this becomes 0.9949, 0.9949, and that's what we wanted. Okay, so that means our R is equal to 9, as we got using the tables as well. Try and reflect it. I will use this skill again with a little shortcut in hypothesis testing video. I mean a slide. Part C is straightforward. Just recap again. So we got K and R's values. So I'm looking for, once again, if you're struggling, people, if I mean not struggling, even if it's you're working it first time, just check. You want X is 1, 2, you want up to 9, right? So want right from 0, you want up to 9. That means I need to work out probability X is less than or equal to 9 using calculator BCD. Okay, take away what's the biggest value I do not want is, because I want 1, Biggest value I don't want is 0, so let's take away probability x equals to 0 or less than equal to 0. Right, so I put these two things in the calculator and work out the answer. All right, so same question now. It is in terms of context, word problems. We have to do what we have to change these words into the known inequalities or equation forms binomial and work the answer out. We'll have a look again, same thing. Try and see if you can make sense of this, then we can do this together. Pause the video. A factory produces the components for the motor trade and 5% of the components are defective. So that 5% tells me this might be the probability I'm looking for. Okay. A quality control officer regularly inspects a random sample of 50. So that's my N. Find the probabilities. First of all, describe that XB, the number of components were faulty. That's binomially distributed and 50, 0.05. Okay, and I'm looking for in part A, I'm looking to work out probability. The fewer than 2, that means x is less than 2, fewer than 2. I need to change in the form which I would like to see that, less than equal to, because 2 is what you do not want. So the biggest number which you do not want is 2. Use the calculator, work the answer out. And for the part B, I want probability x is more than 5. That has to be changed. So 1 take away probability fewer than 2 should be 1. What I'm doing, man. Okay, it should be 1. So I want less than 2. So that means biggest number I want is 1, right? So it's 1. So over here, it's I want more than 5. So I do not want 5. That's the biggest number. So put that in the calculator to work these two answers out. And then we look at part C. Let me clarify one more time, people. X is less than 2. That means I want up to 1. So that's why it's 1. So I was thinking something else at that time. Okay. That's the answer. What do? We use B, C, D, and NP is there. I put X equals 1. I do here B, C, D, and put X is equal to 5. Then take away that answer from 1 to get that. Okay, so part C, it says the officer will stop production when um when the factory sample is greater than a certain value D. So if X is greater than D, he will stop production. Okay, and obviously we need to figure out when does that happen. But they've given you find the value of D. Okay, find the smallest value of D so that officer's top production probability of that happening is less than 5%. So I want to figure out find D. So this is less than 0.05. Okay, so once again, let me just rewrite this in the form I would like to look at these questions, and that one would be this is 1 take away probability of x less than or equal to D less than 0.05. Rearrange, take that whole negative thing to the other side and bring the 0.05 to this side, and that should give you 1 take away 0.05 is less than probability of x less than or equal to D. That means probability of x less than or equal to D is greater than 0.95. So in my calculator or the tables, unfortunately can't see tables. Tables I have only go up to 40. I need to work out this T. Okay, so guys, calculator list function, first time when the probability crosses 0.95, try that. This function, I don't know how high I will have to go, so I've just pressed first few numbers. So I want to find the probability when it crosses 0.95, and this hasn't. Only up 3 goes up to 0.7604, getting closer. So what I'm going to do, I'll type in some more numbers for the x. So when I typed 5, I got 0.9622. This is the first time it crosses this. That is the smallest value. So D is equal to 5 because when x is less than or equal to D, it crosses 0.95. We wanted it to be bigger than 0.95. So that is the value of D, the smallest number when production can be stopped, or he will stop production because now we reached to the last major skill, which is hypothesis testing in binomial distribution. There are 3 types of questions, 3 or 4 types of questions in here. So we'll do that one by one. This is hypothesis testing, one-tailed. Okay, so have a look at that, and then I will do this with you on paper in my board. Okay, the first question on hypothesis testing. First of all, how do you know it's a hypothesis testing question? It clearly tells you the level of significance. There'll be word test used somewhere. Okay, so what is this? A customer owner believes that 25% of the customers, this is the proportion or probability, will buy cheese and onion. He finds at least 30, last 30, that's your n, the sample size, and only 4 customers bought this, that is X. Okay, very important. Step 1 is we write down our test statistics. X is number of people buying cheese and onion crisps. Okay, so X is binomially distributed and sample size is that 30, and we assume that probability which C claims is true, so 0.25. For any test, the first mark will be given to you if you write down your H1 and H2 not, and H1 we test on probability. Probability he claims is 0.25, perfectly fine. And H1 is, what is the after that? The claim it says, evidence suggests that probability is lower than 25%. So that is what we're testing against. 0 point is less than 0.25. Very important point over here. If you write down H naught equals 0.25 and H1 equals or less than 0.25, people, you do not get any mark for this. That's 0. Even one of them is written like this, that's 0 mark. Otherwise, this part gives you first mark, even if your question is not. This is independent mark, it gives you first mark. Okay. Now, very important now, the xn is 30 and experiment x was 4. But what do we test? Always remember this, I'll repeat. You always test in the direction of the null hypothesis. And in the direction of alternative hypothesis. Repeat, in the direction of alternative hypothesis. So alternate hypothesis less than 0.05, you always test less than or equal to this. If this was greater than, you would have tested greater than. So people work the probability out. This is binomial CD straight away. Work that out and see what the answer. Then I'll tell you the next step. Okay, so it's 0.0979. People, now comes a very important decision. Understand it now. So that means this is 9.7%. Okay, that means probability of this happening, that 4 or less people buy cheese and onion crisps, was 9.7%. We set a boundary for ourselves at significance level was 5%. Okay, we thought if it's less than 5%, then we will take notice of that test. If it's more than 5%, we'll say it's so big, not a big deal. Okay, there was 9.7% of chance of this happening. It's happened, so it's okay. So people, what it is in terms of the context, listen very carefully. Understand this. If your answer is less than significance level, that means you need to take notice of this. This is a significant test in that way. We need to, this is to be surprised, amazed, wow, that happened. So I have to take notice of that. Then you have to reject H naught, the old thing, and accept H1, the new thing. Okay, remember that. And if your answer is greater than significance level, then you say no big deal. There was a lot of chance of this happening. So what did that happen? So that means we accept H naught. So in this case, what we do? We accept H naught. But people, that is not enough. We have to write answer in terms of context as well after that. That means what? The probability of people buying cheese and onion is not less than 25%. Okay, because that's what the context was. The probability of people buying cheese and onion is not less than 25%. Okay, we accept the original thing. The probability is 25%. That is the first example of hypothesis testing on one-tailed. So this is the second example, and identify if it is one-tailed or not. Obviously, I've given you a hint that this is one-tailed. We're going to identify how. Let's see how do we figure that out. Okay, have a look. We work together. All right, so do the normal thing. People identify what it says. This is the probability. 15 calls is a sample, that's n. 9 calls is the result, that's x. And it says there's an evidence more calls are now queuing for more than 5 minutes. So that means this is one tail test, but it's in the other direction this time. Okay, people, can you now do for me? Identify what the test statistic is, turn the distribution, and write down H0 and H1. That is my test statistic. Let's write distribution and null and outlier hypothesis for me, please. This is your test statistic distribution and null and outlier hypothesis. And then I said this result is x is equal to 9. We always find the probability, or we test in the direction of H1. So I need to work out probability of x greater than and equal to 9. Remember that we always test in the direction that is greater than or equal to 9. So people, how do you figure that out? So I want this probability, okay. And how do you find that probability? You do 1 minus probability of x less than or equal to 8. Work that out, and then we compare with the significance level. It is 0.0152, and we're comparing this with 1% significance level. I write down my answer is 0.0152, and this is 0.01. So my answer is greater than that. Okay, I will let you write that decision now. What happens? My answer is bigger than significance level. That was the boundary we set. So probability was more than that boundary. So what it happened then? There's no big deal. Okay, that means we accept H0. Okay, so whatever was originally happening is fine. So what does that mean? The probability of the calls waiting for more than 5 minutes is not increased. Okay, there's not increased. The probability of waiting more than 5 minutes is not increased. Okay, so that's for the second example of hypothesis testing, one tail test. We did one in the less than direction, we did one in the higher than direction. Okay, move on to the next one now. Next question, this is two-tailed. I tell you why it says two-tailed, because it's a test at 5% level of significance, whether the proportion of complications differs from the national proportion. That means it doesn't say if it's more than or less than. Differs means it can be in any direction. Table, can you do this for me, basic steps? Can you write down the test statistics, distribution, and H0 and H1? Then we work from there. So this is what it is. X is people experiencing complications, number of people, X is binomially distributed this, and H0 is probability is equal to 0.2, and H1 is probability is not, because you don't know which direction. That's what makes it two-tailed. So people, very important, the first skill which you need to know. In a two-tailed test, we have to test on both the tails. We don't know where it is. Okay, so then significance level will be divided by 2, and it will be 2.5%. That means we're looking for 0.025 as the probability in each tail or anything closer to that. Very important, you understand that. Now I'm going to do the next step with you. This next step is really important. I would like all of you to listen to this very carefully. I've got the result, X equals 8 patients, okay, from a sample of 20, and probability was 0.2. So I'm expected to test in both of the tails, but I can do a shortcut. I can do a little work in here to test only in one of them. So what do, people? You find the mean of binomial distribution, which gives you 20 times 0.2 is 4. And your result is bigger than 4. That means you test only in the upper tail. So you need to work out test only in the upper tail. So that means you need to test probability of X less than, greater than or equal to 8, upper tail only, and that is less than 0.025, because the significance level needs to be divided. Okay, we're going to test if that happens. We're going to compare this with 0.025. Okay, let's have a look. So this will be 1, take away probability of X less than or equal to 7. Work that out using BCDs and compare it with 0.025. Got 0.0321, which is greater than my significance level. Remember, it was less than 0.05, but we had to divide significance level by 2 because it's two-tailed test. Right, answer is greater than significance level. One more time, so no big deal. That means we accept H0. Okay, what does that mean? That the probability of people suffering those complications is not different from the national statistic. Okay, could write that in context. Okay, the last question in this series then, it is a critical region question. We need to find the critical regions. It's two-tailed as well. Can you see over here? It's two-tailed. Okay, and then we have to find the actual significance level. So just to avoid video getting too long, can you please write down the basic stuff, distribution and H not H1. Let's see. It doesn't ask you to work out H not H1 actually. There's no test, so we can just do critical region straight away. Okay, so I'm not going to rush on this one. Um, Probability is 50%. Sample size is 20. 5% significance level. Critical regions of the two-tailed test. What does that tell you, people? We have to split this into two parts. It's 2.5% in each tail. So critical regions. Let's say the critical regions are x is less than or equal to a. You need to find that number a, and x is greater than or equal to b on the upper tail. Right? So what does that say? The probability x less than or equal to a should be less than 0.025, 2.5%, half of that. And over here, probability x is greater than or equal to b should be less than 0.025. And it says in the question that the probability should be, either tail should be as close possible to 2.5%. Okay, we have to be careful about this. Right, so we can use tables or we can use calculator. I'll use calculator for you just to show what if the table doesn't have the values which are given to you. So on the lower end first, I have typed in the list function, binomial CD, 20 and 0.5, and I've got my answers. My first answer for 0 is 0.0387. I wanted answer to be less than 0.025. So this is already bigger, so that is the closest. Then that means critical region on this side is 0. So question set, it should be closer to 0.025, even though it's not less than that, but that is the closest. So that is my critical region. Obviously, we can't go any lower than 0 anyway. Okay, that's my critical region on the left tail, and this is the probability of that critical region. I want to work out the critical region on the right tail. This is really important. People pay attention. So that's what you have. I'd give you a shortcut. There's a lot of methods. There's a shortcut first, then I'll teach you the method as well if I need to. Okay, people, what do you need to do? Say it yourself. Calculator does not give me probability in this direction. So what do? I swap the inequality. Then I take away 1 from it. Swap the inequality. Just remember swap and take away this from 1. Okay. Have a look. There's pause it and check, and I will tell you why does it work like this. Yeah, let me just explain that to you now. Probability for x is greater than or equal to b is less than 0.025. And this is what? 1 minus probability x less than or equal to b minus 1 is less than 0.025. Okay, so I take that to the other side and bring that to this as 1 minus 0.025 is less than probability of x less than or equal to b minus 1. So that gives you probability of x less than or equal to b minus 1 is greater than 0.975. So all this working leads to the same shortcut, which I repeat again for you. So what do you do here? You swap the inequality, take away 1, swap the inequality, take away from 1. So this is what we're looking at now to work that out. I need to find this value of something which is greater than 0. When probability is greater than 0.975. List function upper tail one more time. So list function upper tail, as we went down the order, I got for 5 is 0.93, for 6 is 0.978. That's the first time it crosses 0.975. We want it bigger than 0.975. So I got it 6 here, people. So probability of x less than or equal to 6 was 0.978. So 0.978, and I want that. Okay, so that means my b minus 1 is 6 and b is equal to 7. That means my critical region, people, for on this tail is, it is x is greater than or equal to 7, and the probability of that is, it is 1 minus 0.978. Let's find that probability using calculator. So that is my critical region. That's my probability. And probabilities now will help me to work out part B of the question is actual significance levels. Understand this, learn it rather. Actual significance level is the probability of the critical region added together. Probability of the critical regions. We add these two probabilities there. So I get 0.0388 plus 0.022, and that should give me the actual significance level, the answer to part B. Okay, significance level people. So this concludes this whole presentation, whole video, and hope this makes sense. Thank you very much. So actual significance level is this, and that's it. Thank you.